Let's go ahead and wrap up this section by talking about a couple systems of inequality word problems. Now, in another section, we are going to spend more time looking at how to solve and identify solution sets to just inequalities outside the context of a word problem. But I figured this was a good time to just keep rolling with the word problem train since we're going to be using a lot of the same skills. So Diego works at a scooter dealership that sells two scooter models, a $5,000 standard model and a $7,000 racing model. Last month, his goal was to sell at least 36 scooters. If Diego met his goal and brought in over $250,000 in sales, write a system of inequalities that describes S, the possible number of standard model scooters, and R, the possible number of racing model scooters that he sold last month. We'll do the second part in just a minute. Let's start with that, writing our system. So we want to identify our constraints. What are our constraints? Okay. So our constraints are that he needs at least 36 scooters and he sold over $250,000 in sales. So those are the two constraints. Those are going to be the two equations that we will model. So at least 36 scooters, that's going to be greater than or equal to 36. And in order to total up the number of scooters, well, we just take the number of standard model scooters that he sold, which is S, and the number of racing model scooters that he sold, which is R, and we sum them up. S plus R has to be greater than or equal to 30. The second constraint that we're looking at is the $250,000 in sales. He sold greater than or equal to $250,000 in sales. Actually, since it says over, it means he did just greater than $250,000 in sales. $250,000 in sales. Okay. And that's going to be based on the sum of the number of scooters sold, but we also have to attach in the price value for each one sold. So $5,000 times the number of standard scooters plus $7,000 times the number of racing scooters. Now that answers the first part of our question, is write a system of inequalities that models that scenario. That's what we did right here. There's our system. Now it continues on and says, well, if Diego sold 10 standard model scooters, what is the minimum number of racing model scooters he must sell and still bring in over $250,000? Well, again, with systems of linear inequalities, we can't really solve them the same way that we do systems of equations. And so we have to look at the constraints and find the least possible value within a combination set that satisfies both inequalities. Well, they started by telling us he sold 10 model scooters. So we can actually take both of these inequalities and rewrite them as 10 plus R is greater than or equal to 36. And then 5,000 times 10 plus 7,000 R is greater than 250,000. And so now what we can do is solve for R independently for each of these. Well, for our first inequality, if we subtract 10, we get that R has to be greater than or equal to 26. And then we can solve the second inequality to see how it compares to the first limitation. So we can take 5,000 multiplied by 10, and we get $50,000. We subtract $50,000 from both sides, we get $200,000. And we divide both sides by 7,000, and we get approximately 28.57 with some rounding. So now that we have this value for R, we have to kind of compare and see what is the smallest value that makes both inequalities true. So our first one is any value of 26 or greater. So we have 26, a little number line here as an example. We have 26, 27, 28, 29, and so on. Our first inequality can be graphed as starting at 26 and then any value to the right, that is greater. So any number in that range makes our first inequality true. Then here, we're looking at 28.5, which is approximately right here, and then R has to be greater than that value. R has to be greater than that value. So again, we're shading to the right and anything that's in that direction. And so the lowest value that makes both of those inequalities true, given that we cannot sell part of a scooter, is this number 29. We have to sell at least 29 scooters of racing quality in order to satisfy the inequality. Now, something I encourage you to do, especially after our next example, our next lesson on graphing inequalities, is to go into Desmos or a similar graphing program and graph both of these inequalities on the same plane. You're going to have to replace S and R with X and Y, but you'll get the idea. And with an inequality, you'll find that your solution is a shaded area. And the solution to a system of inequalities is anywhere the shaded area overlaps. And so since we've identified that 29 is the minimum value if he sells 10 standard scooters, we have a solution set as the point 1029. And what I want you to do is check to see where this point falls within the shaded regions when you graph both inequalities. Now, our last example, Eugenia wants to buy at least 30 prizes to reward her students throughout the semester. Prize pool will be made of small and large prizes, which cost $2 and $5 respectively. Her budget for the prizes can be no more than $100. She wants to buy at least 15 small prizes and at least 5 large prizes. Write a system of inequalities that represents the conditions described if X is the number of small and Y the number of large prizes. So we have several different conditions that must be met. The first one is at least 30 prizes. So we can start with at least 30 prizes, greater than or equal to, and the sum of the prizes is just going to be X plus Y. X plus Y has to be greater than or equal to 30. X plus Y has to be greater than or equal to 30. Then our second condition is that she does not want to spend more than $100. She wants to spend less than or equal to $100. And the total cost will be $2 per small plus $5 per large prize. But those are not our only conditions. We actually have 2 more conditions. She wants to buy at least 15 small prizes. So at least greater than or equal to 15 small prizes. Small prizes are X. And then last but not least, she wants to buy at least 5 large prizes. Y has to be greater than or equal to 5. So this is our system that models all of our constraints. And then if we wanted to see what possible combinations would fit all of these constraints, we could graph all the inequalities. And again, we are looking for any overlapping areas for all of the solutions.